Hello, this is Scholar Strategy. It's Matt. Today we're going to look at probability. Probability is the likelihood an event is to occur, represented as a number from 0 to 1. Example, flip a coin. Probability that it lands on heads is 50%, 0.5. So there's either heads or tails. An event is an outcome or collection of outcomes. So flipping a coin is the event. Outcome is the possible results. So if I flip a coin, so in the event of flipping a coin, the outcomes are heads or tails. The probability continuum ranges from 0 to 1, being 0 being impossible. So that would be something like if today was Friday, for example, then the chance of the next day being Sunday, like tomorrow being Sunday, that would be 0%, right? And no, we're not going to go into like theoretical time travel or anything like that. In the middle, flipping a coin, it's 1/2. And then there's 100% chance that the sun will rise tomorrow. Or something very obvious. I know that like in the world explodes, it's not going to rise, but you know what I mean. Theoretical versus experimental probability. So theoretical, so let's have the left circle be theoretical. Theoretical. And on the other side, experimental. So this theoretical is what should happen. This is the probability equals the number of outcomes over the total amount of outcomes. And then on the experimental side, you run the experiment and you find out what actually happens. Number of trials of A over the total trials. So if I was flipping a coin, for example, theoretically, since there's only 2 outcomes, heads or tails, we should get one out of those 2, and one of those 2 is either heads or tails. But in reality, it is very possible that I keep flipping this coin maybe like 10 times, and 8 of those 10s were heads, and 2 of those 10 were tails. That's possible. But as you keep flipping that coin more and more, maybe 100 times, 1,000 times, it should get closer to the theoretical. Both of these are ratios from 0 to 1. It determines the likelihood of an event. And always reduce your fractions. So probability examples. So you roll a standard 6-sided die. Find each probability of rolling. Find each probability of rolling each. Find the Okay, are these theoretical or experimental probabilities? So the probability of rolling a 5. So first off, all of these is theoretical, because I'm not telling you to go run trials, grab a dice, and keep rolling. So these are all theoretical. So what's the probability of rolling a 5 in a 6-sided die? So there, out of the possible outcomes, you can have a roll a 1, you can roll a 2, 3, 4, 5, or 6. Probability of rolling a 5, there's only 1 out of the 6 possible outcomes. Probability of an even number, we have even number being 2, 4, 6. That's 3 out of the 6 possible combinations, so 1/2. You have a 50% chance of rolling an even number. What's the probability of rolling greater than 2? So not 2, greater than 2, 3, 4, 5, 6. So that's equal to 4 out of 6 possible combinations, or 2/3. So 66.7% chance of rolling a number higher than 2. A community hosts a talent show. 7 musicians are scheduled to perform. The order of performance is randomly selected. What is the probability that the musicians perform alphabetically by last name, assuming no 2 musicians have the same last name? Okay, so probability means number of outcomes, which means 1. You can only have... So this outcome can only be achieved once, because only one alphabetical order. And then the total number of outcomes is 7 factorial. Because if you choose the first musician, then there's 6 left for the second musician, and then there would be 5 left for the third position, and then so on, so on, so on. So there's 7 factorial total number of distinguishable orders. So that's 1 out of 5,040. You are friends with 4 of the 7 musicians. What is the probability that the first 2 performers are your friends? Okay, so this event can happen. So we have 4 of the musicians are our friends, and we want to choose 2 of them to go up first. And then the total number of outcomes is, we're choosing 2 of yeah, the total number of outcomes is, we're choosing, well, we're just, out of the 7 musicians, we're choosing 2 of them. Okay, so let me write this here. So 4 are your friends. You want to choose 2, and their order isn't important. Down here, there's 7 musicians total, and we're just choosing 2. That gives us the total possible outcomes. So we plug this in there and get 6 over 21, which is 2 over 7. All right, the Wheel of Fortune is located below. Find the following probabilities. Probability of being bankrupt. Now, assuming that each of these are the same size, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 spaces. Okay. So the probability of landing a bankrupt, there is only one bankrupt out of the 24 possible spaces. 250, that's, whoa, okay, I'm making it hard. There's 1 250 here, there's 1 250 here, there's a yellow 250, and that's it. So there's 3 possible ways we can get this 250 out of the 24 spaces. Don't forget to reduce. Okay, what's the probability of getting less than 400? So not including 400, but less than 400. There is, just to save some time, 18 out of the 24. So you have a 75% chance of landing on something less than 400. Okay, part D, earning no money. So that would equal to, there's 3 spaces. There's the bankrupt space, where you don't get any money, you actually lose all your money. You can lose a turn, or the free spin. So 3 out of the 24, 1/8. East High's Key Club puts on a blood drive. At the blood drive, the type of each blood was logged and recorded in the table. Find the probability that a randomly chosen sample will be type B. Okay, so we're looking for the probability that we choose blood type B. Okay. So 22 donated, or blood type O, there was 22 blood type O's, 21 blood type A's, 5 B's, and 2 AB's. So first off, we need to know the total number of possible outcomes. That is 22 plus 21 plus 5 plus 2, which is 50. So the probability is 5, because we're trying to choose B, out of the 50 that we have, so 1/10. And this would be known as an experimental probability. Because we know the number of each blood type. Otherwise, if we didn't know blood type and all we know was that there was O, A, B, and AB, it would just be 1 out of 4 chance. But since we knew the number of donations, that changes our probability. Let's do some more examples. You draw a card from a standard 52 card deck. Find the probability of each event. Probability of drawing a 10. There are 4 10s in a deck of 52. Probability of drawing a club. There are 13 clubs in a deck. So you have a 25% chance. And the probability of a red card, there are 26, so, or half red, half black. Which is more likely? The probability of the shaded area, the probability of the shaded area, or of the white area, or of the white area. Justify your answer. Alright. So we're going to do this. We need to find the area. So probability of the white is just area of the white circle over the area of the whole circle, or the big circle. one way to look at it is we're looking at the area of the donut hole, area of the hole over the area of the whole donut. If that makes sense. So area of the white circle is just pi r squared. So pi r squared, and area of the big circle is also pi big R squared. So this would be pi times 7 squared. That's the radius of the white circle. Total radius of everything is 7 plus 14. So pi times 21 squared. So this will give me 49 pi over 196 pi. Pi's cancel, so we're left with 1/4. So this is a 0.25, which is 25% chance. Probability of the shaded region, similar. Area of the shaded region, which is pi big R squared minus pi little r squared. That's how we get the area of the shaded region. You take the area of the whole circle minus the area of the donut hole. And on the bottom, we still have the area of the big circle. So that's going to be equal to 196 pi minus 49 pi over 196 pi, which will be 147 pi over 196 pi. Pi's cancel, and we're left with 3/4. So there's a 75% chance. So the answer is probability of the shaded, because it has a 75% chance of being selected. So, for example, if you threw a dart and it had to land on that circle somewhere, it has a 75% chance of landing in the shaded region. A marble is drawn from a bag containing 6 blue, 6 yellow, 9 white, 11 green marbles. Find the probability of each event. The probability of blue or yellow is the same as the probability of blue plus the probability of yellow. So that's equal to, probability of blue is 6. So there's 6 blues plus 6 yellows out of the 32. So 12 out of 32, which is 3/8. Probability of not green. Okay, there's 32 of them, and there's 11 not green, so what's left over? 21 that are not green out of the 32. And then probability of red. Well, there are no red marbles, so 0. 0% chance. Exam grades. In a history class are shown in the chart. Find the probability that a random chosen student in the history class received a C or better. Is this experimental or theoretical? This is experimental. Because it is what that's because we already know the test grades. If we didn't know at the start, theoretically, any student can make an A, B, C, D, or F. So let's count these. This is 3, this is 1, this is 8, this is 12, this is 7. And we want to know received a C or better. Okay, so that would be 8 plus 12 plus 7. So that would be 27 out of, how many students were there? 3 plus 1, which is 4, plus 8 is 12, plus another 12 is 24. 31 students. So 27 out of 31 students got a C or better. So that's pretty good. If you want to change this into decimal, this would be 87.1% of the students have a C or better. It's pretty good. Hopefully this helped you out. Have a good day.